principles I think you're doing.
Yeah. That's the average derivative thing.
Yeah.
This is like the anti that.
No, not really. I'll tell you what it is. It's a very easy idea, and then once you understand the theory, you don't have to memorize the formula. Okay, it's on your formula sheet too. Here we go. Average value of a function is like this. If I gave you a shape like that, and I said the area between, let's say, 1 and 2, I always like 1 and 2. Area between that, hypothetically, if I told you was 10 squared units, okay, hypothetically, then average value function just basically means if I keep the same width, so I want to do it in red, if I keep the same width, which is a distance of 1, on the function, what value, what height can I do on the graph here? Okay, what height will give me a rectangular area the same? That's what they're trying to say. So, let's say if I chose this C value here, okay, then it corresponds to this point. This height here, multiplying to, so that tells me this is f of C here. Sorry, this is, oh, wait, sorry, I got it the other way around. How do you, well, it's not rubbing off, all right. So let's say that's C and this is f of C, okay? What I'm trying to say is, there has to be a value in between 1 and 2, okay, a value between 1 and 2, which we call C, such that when you hit the curve, that's the height of the rectangle to give you exactly 10 squared units. Okay, so that means if this is a length of 1 to 2, that's 1, and you know you need 10 squared units, you know the height has to be 10. Because if it's 10 times 1, you're going to get the same area. That's all. That's what average value basically means. And so if you think about the formula, which I'll show you in the next page, it makes a lot of sense because the formula is just simply the same distance, which is 2 minus 1. Oh, wait. Here we go. So if you look at this one, it looks really like different to what you're familiar with, right? But if you oh my God. All right, here we go. I know, technology these days. I'm going to draw it again just so it's all clean. 1 to 2. Let's say C was here, and that's the height. Okay, so this is f of C. Okay, so you've got this rectangle here, and it gives you exactly the same area. So if it gives you exactly the same area as finding between 1 and 2 of f of x dx, which I said was 10 before, right? Let's say we want that to equal to this height multiplying the width. Now the width, you would say it's 2 minus 1. Agree? Yeah. 2 minus 1 times the height, which we know is f of c. Agree? So I'm going to write that on the left-hand side. You're just doing the area of a rectangle. You're just saying f of c, which is the area of a rectangle, times 2 minus 1. Agreed? Okay. Now, this formula, if I don't use 1 and 2, this is your lower bound, that's your upper bound. I can call that A and B. Yeah. This is then B minus A. True? Yeah. Okay. So if I write that, this is where the formula comes from. It's very straightforward. It's just simply f of c times B minus A is equivalent to the antiderivative of A to B of f of x dx. True? Okay. So if you want to find f of c, which is the average value, that's what f of c stands for. F of c is the average value. That's the value that makes sure that you get the same area. If you want to get f of c by itself, you divide both sides by b minus a. True? So that's times b minus a, divide both sides by b minus a, you get f of c. And that is your formula. Because all it is just saying width times height is equal to the area that you want. And that's the formula on your sheet. It's nothing special. It's just a rectangle. It's just saying width times the height, and all I've done is I've just moved it across. So if you have a look at this, I'm just going to rewrite it again. Remember I said f of c times b minus a. So that's the width. That's the length, or the height of a rectangle. We want it to be the same as the area of f of x dx between a to b. Okay? And if you just divide both sides by b minus a, f of c will equal to b minus a times a to b f of x dx, because you're dividing both sides by b minus a. Okay, but the theory, what you need to understand is just, if that's the area under the curve, which is integration of f of x between a to b, we just want to know what the value is, what's f of c, such that timesing by the same width, height times the same width, this rectangle has the exact same area as that. That's what we did. F of c is the height times the width, gives exactly the same area. What's f of c? Divide both sides by b minus a, and this is your formula for average value function. That's all it means. Okay, so the reason why I keep emphasizing that's all it means, because in your questions in the exams, which I'll show you, those questions are just asking you, they tell you the area. All you had to do was look at that and say, well, 1 times what will give you that area? Because most of the time it's 1. It's like, could be 5 to 6, and they'll say, find the area, and it's just distance of 1, so what's the height to get the same area? And they tell you what the area is.
Can you just be like, oh yeah, f of c is this because I looked at the width and the area.
Well, it's multiple choice, so normally just say the right answer. Okay? Does that make sense theoretically? Because that's all you're doing. If you don't understand it theoretically, then copy that formula down. But they ask for average value, that's what you use. It's only when they start getting you to think about the average value that you might not get it right. So that's why I'm trying to give you the theory for it. Okay? The theory is just, it's a rectangle. F of c is just the height times the width that you currently have, the interval. That gives you an area, but you want the area to be the same as the area under the curve of the same interval. That's all it is. Okay, and we'll call that the average value. Okay. Now, let's pick an exam question so you can see what they do. Where's an exam question? Let's start off with an easy one. Here we go. Let's try this one. 2010, 2012, let's do 2010. They say the average value of the function, so you've got this function here, okay? For between 0 to pi, so they tell you 0 to pi. Okay. And in this case here, if you want to find the average value function, which really means just find that height to give you the same area. Now, because this is a CAS work, you can do this on your CAS simply. Okay, so if you know your formula, it's simply to find f of c, which is the average value, it's 1 over the interval, which is the width of the rectangle. Okay, the width of the rectangle, which is 0 to pi, which is pi. And you don't know what the area is. Well, the area is currently between 0 to pi of e to the 2x cos 3x dx. Type in your CAS, you get your answer. Easy? Okay, so it's not average rate. Average value and average rate are two totally different things. Okay, one is for, average rate is the y2 minus y1 over x2 minus x1. Average value is the height such that you get the same area. Okay, so one's area and one's a rate. Okay? I'm just looking at the next one, whether that's oh, yeah, next one's good. I want you to have a look at the next one. Have a look at the next one. The average value of a function 0 to 2 pi, okay? So you've got a function that's between 0 to 2 pi sine squared x over the interval 0a. Oh, okay, so you've got an interval from 0 to a, is 0.4. So think about it. What did they just tell you? What is 0.4 right now? What's 0.4 right now? What's the 0.4 representing? So read the question properly. What did they just tell you? What's 0.4 equivalent to? The average value. It literally said the average value of the function, and then you ignore all this, is 0.4. Okay? So they literally just said to you the average value of the function is 0.4. Okay, but they tell you the interval. So read the question properly, yeah? They word it that way, but really just try to understand what they're telling you. So they just told you this is 0.4. You've got 0.4 here. You know the interval is 0 to a, so that's 0 to a. A minus 0 is a. Okay, you know this is 0 to a as well. How do you solve? Oh. Okay. How do you solve? You go to CAS. Once you can do that one, I'll give you another one where you start thinking. Okay, so this is all playing around with a formula. I want you to do one where you think, which is the next one. Next one's a nice one. Very easy one for the next one. Think. So this one, they just simply told you f of c equals 2.4, interval a to b. So therefore,
I was waiting for like some, what do you call it again? No, I was waiting. Change it.
That's great.
That work with X, do I turn A to A?
26.27. He's going to see.
It's all CAS work from here. So define the function, make sure you got your 0 to 2 pi, and to derive 0, a, and let it equal to 0.4 and solve. It's all CAS work. You see, it's not tricky. It's not a tricky problem to do. All CAS work. So I'll just show you the solutions there. It's all CAS work. If you type in your CAS solve, answer C for the second one, 66% and 60%. Now, I'll show you the ones where it starts dropping. Okay, so these are ones where you use a formula and you're playing around with it. Huh? 60%.
That's highlighted here. Like you're gone.
Okay, let's try another one. Is it this one? Yeah, all right, we'll do 2009 before we do the 2015 one. Here we go, average value, same idea. So read the question properly and then see what you need to find. You got average value of the function. You got a rectangular hyperbola. Asymptote is at y equals to negative half. I mean x equals negative half. The interval is between 0 to k and is 1 and 6 log E7. Technically, this is exactly the same problem as the one you just did before. Because they told you the average value of the function is 1/6 log E7.
Yeah.
Okay, and they tell you the function, they want you to find k.
Last slide.
Last slide, this one?
Easy flat.
So it's exactly the same one as 2012 exam 2. So 3 years later, they used the same question. Just change the
You got it wrong.
function.
Are you doing already?
C, 1.298. Because you can't have negative. A is between 0, A is greater than 0. You got B? Did you type in the square?
Yeah.
Function.
Did you square the x or did you square the sign?
I put in brackets.
Like,
That's all I did.
Oh, you know what you're missing? You're missing the 1 and 8.
or debate it.
1 and 8, the interval. They got you with B. All right, here you go. Just in case you're doing the question 18, same drill. It's exactly the same thing. Do it on your CAS. Type in the solve, 1 on K, exactly the same way as the last question. Okay? And you should get B as your answer. 52% got that right. That's exactly the same question as 2012.
So what's the last question?
1.298, I think it was.
I got it.
It's B. What?
It's not what that is. And it's not that, it must be C. It's pretty.
Very good. K has to be greater than 0.
Oh, it's the simplest number there.
Yeah.
Just baiting you.
But you can see 50 it was 60%, went to 52%. I'm just picking out average value questions that I noticed throughout the years, yeah? A and D. I don't know what A and D.
It's, no. I feel like people pick A and D.
Why?
Because it looks the hardest.
It's
Hey, come on.
too simple.
Yeah, it's.
Hmm.
Wait, is that?
Did they make a mistake somewhere?
Why is that actually
It's
C?
B.
Yeah, but why is it highlighted?
It's highlighted on 52.
Oh, I was like,
Alright, this one's a nice one. Try 2015 and then I'll give you the last exam question which uses average value, the theory of average value. But this is a nice one. Really think about it. Okay, so it's 2015. It's pretty close to you guys. It's not far away.
What was the answer to the last one?
B.
And what was that?
3.
3. That's false.
it's one of the answers. You get given the answers and then one of them C.
Yeah.
Alright, let's go.
2.5.
Try this
E
one.
minus.
Really think about the problem. What have they given me? What am I looking for?
Ah. Oh. The area of the shaded region. Wait a minute.
So that's.
Hey.
Two things would be 2.5.
Okay.
Remember, they didn't give you a function for this one, so you have to look at the graph. If they gave you a function, it would be a bit easier to do. Look at the graph, think about it logically.
Wait, no,
Wait,
it's
wait,
sorry.
wait.
Plus 2.
The key part to understand is the 0 part. What do they tell you average value is 0? What does it imply if you say average value is 0?
Wait.
Yes, F of C is 0.
So like the area of that string from A equals unsolved and then you cancel each other out. Therefore, the triangle is 0 to PP must be 3 so half
Very
P
good.
squared equals 3
That was the key step. So, this is the key part. Average value is equal to 0. You had to understand. See, f of c, which is the average value, is equal to 1 over b minus a antidiff of a to b of f of x dx, right? That was the formula.
Yeah.
If you say that f of c is 0, because they said average value is 0, then, and the interval was between -2 to p, then really it's just p plus 2 between, 2 to -2 to p of f of x, which I don't know, dx. True?
Yeah.
Now, if you want to get rid of this, okay, times both sides by p plus 2. True? But if you times both sides by p plus 2,
Yeah, 0.
you get 0. So this is the key part here. We're saying 0 is equal to -2 to p of f of x dx. Now, this is very powerful here. They're saying that the area between -2 to p, which is -2 to p, the area, remember when you're finding the antiderivative, we find the net sign. This is exercise 11F. If the net sign is 0, and you already know that this shaded region is 25 on 8, how is it possible to get 0? What's the key thing in 11F?
It has to be the same for that side.
Yeah, because this is a negative area. So this is negative 25 on 8. That means this has to be 25 on 8 for you to cancel it out to be 0. That's the only way to get from an interval, if you integrated from here to here, the only way to get 0 is they have to be equal. They have to be equal in order to have that. Yeah? Otherwise, you have to switch the signs to make it positive. But they told you the integration, this is the first step. You're saying from here to here, 0, and you didn't split up the interval. So that means net sign is equal to 0. That means negative and positive have to be the same values. Okay. They told you this is 25 on 8, so that means this is 25 on 8. But the cooler thing is, you don't know what the equation is, you don't need to. That's a straight line. If you think about it, that's a triangle. If you draw it out, the interval from P, this area is just the area of a triangle. You know the distance is P, you know the height according to the Y value is P, half base times height. Half base times height. So the half, your base, times your height, has to equal to what? The area of this triangle has to be 25 on 8.
Oh.
And suddenly, which I'll just delete all this so it's neater, you get P squared on 2 equals 25 on 8, times both sides by 2, you get 25 on 4, square root both sides, you get P is equal to plus or minus 5 on 2, but since you know that X is greater than 0, therefore P has to be 5 on 2. Okay? Now, wasn't that a cool question? Because that really delves deep into how much you understand about area below the graph, integration, which is net sign integration, and then talking about average value. What does it mean when you say average value equals 0? And really play around with it and think about it. Okay?
What exactly is average value?
So it's just a value in between an interval such that you get the same area. And the reason why you use that is like, you know, Coke can, or even Mother. You guys knew the very first Mother can. They wanted to keep the same volume. No, actually it was a Coke can. They wanted to keep the same volume, but how do they change the diameter or the radius to keep exactly the same volume? So this is exactly the same problem where you want to keep the same interval, but what do you change? And in their case, you can have a shorter can, but a fatter radius to make the same volume. And that's what they calculated. They said, I want the same 375 mils for this can. What can I do? And what they've done is they increased the radius so that it's fatter, but shorter. So they kept the height the same. So the same volume, but changing the radius. And that's what we're doing here. We're saying, keep the interval, but what are we changing? We're changing the height. Okay, so this is the original function, but what if I just want same length, but what's the height? What could I have? A rectangular height, the average value to get that same value of area or volume that I want. And that's what they're doing there. Okay. That's the gist of the purpose of having that skill there. Okay.
So it's only used for Coke cans.
Oh, well, I don't know what else you want to do. Like if you wanted to, it could be a table. You want to keep the same materials, set number of materials you have, and you want to change the shape. And what can you change? It's a variable change. What am I changing? The length, the width, the height, the depth. It's up to what you want to change there.
Is it useful for any other math?
Well, I don't know. I just know if you think it in that way, that's why when it comes to like worded problems with average value, it makes more sense what you're trying to do. But a lot of times students will only know average value as the formula. That's why when it comes in the exam and the multiple choice, kids will find it difficult to do because they don't know what they're actually looking for. They don't know what's happening in the problem. See, when I unravel it, it made a lot of sense. But if you don't unravel it and you just think of it as like, well, average value equals 0, f of c equals 0, and it doesn't tell you anything. It's more about reading into what does it mean if the average value is 0, if you're playing around with it, what does it mean if the area is 0, what does it mean when you do anti-diff or integration? And that's key, okay? One last problem. Let's see if you can do this one. Last one, which is a nice, is it this one? I think it was this one. Here we go. Try this one, 2014. Not too long ago too. 2014. Graph of a function h is shown below. Okay, the average value of h is, now if you know and you understand the theory I've taught you so far, you should be able to look at that and tell me the answer. It's question 20, so it normally gets a bit trickier. I'm assuming the percentage will be lower on this one. Assuming. There's no function for them to use. They have to understand what average value means to solve this problem.
does it mean?
The average value.
What's the interval? The interval is between 1 to 11. What's the average value of H?
So you have to remember the theory. What's the theory asking? Area under the curve. I want that to be equivalent, keeping the same width. What should the height be? That's the only thing I need to know. If you need a sort of a Kickstarter, what you need to know is what's the area under the curve. Because once you know the area under the curve, you can figure out what the height should be of the rectangle to get the area you want. Find the area under the curve.
Just for instance, we look at the graph is symmetrical. This line is the same as the other one, just so you can just ignore the other one because the averages are still regardless. If you look at the first one, 1 to 4 to 6 to 10, you realize the average value is just a bit. Yeah. So if you have the midpoint of y, 4 plus 7 by 2 is 7.
This is true. It's like kind of dumb. They should have just designed that like.
Well, isn't that
You're not trying to find the area. You're trying to find the average value graph. When you draw the rectangle, you'll find that the rectangle is exactly the same.
Yes, it's written in a weird way.
So they
But
do science squared x plus squared.
yes, so that's pretty much what they're doing. So you know how you got negative sine squared 2x minus cos squared 2x. Well, then you can take the negatives out as a common factor. What you get is sine squared 2x plus
So you just get negative 1.
2x. And that, yeah, it doesn't matter whether it's 2x or as long as these are the same. That equals 1. Alright, let's do this problem 2014. So, first step is you needed to understand the area under the curve
Unless the graph is not set.
is something. And whatever that is, what we're trying to find is the width of the rectangle stays the same. So we went from 1 to 11. This is a width of 10, right? We're trying to find C, f of C, which is the average value, such that the rectangle has a height that you can find the same exact area. So the red area has to equal to the blue area. That's all you're trying to do, okay? So the first step is you need to know what the area is to begin with. What is the blue area? Now I'm going to delete all of this so it doesn't confuse you. There's a lot of ways to do this. I mean, you can split it up. Because this is 11 to 4, you can actually just split it up like that and do a trapezium, area of a trapezium, and double it if you want, okay? Or if you didn't know the trapezium, you could split it up into a massive triangle on the top and a massive rectangle on the bottom, okay? So either way, it doesn't matter. You just need to find the area, right? So I would do a trapezium just because it's easier. So this is a height of 10, height of 4, from 1 to 6 is 5, and if you've forgotten the area for trapezium is half of a plus b, which is 4 plus 10, and times by the height, which is 5. Okay, and that gives me what? 14 divided by 2, 7 times 5 is 35. So it's 70 in total, because there's 2 sides to it. Okay, so I now know the area, which is any diff between 1 to 11 of h of x dx has to equal to 70. Okay? But remember, we said that we want to find a rectangle, which I'll color in blue now. You know that the width is 10. The width is 10. We're trying to find a height, f of c, such that the rectangle will give you the same area. So 10 times what will give you the exact same area? So 10, which is the width, times what gives you exactly, 7. So the answer has to be D. Okay, but see what I mean by theory. See, if you understand only by the formula, you're going to be stuck here because they only give you A and B, but you don't know what the function is, and you're stuck. But it's not about that. It's about understanding what does it mean when you talk about the average value. You get what the average value is actually representing, then this type of question is pretty easy to do. Okay, but there you go, D. And let's see how many people got that right. 44%. Woo! It's dropping by the year. Okay, but that's what I mean. As it gets easier, if the more students can do it, then they'll have to change it. Okay, so that's good for you. So that if you do get something like this year, if it keeps dropping, it's good for you. You're more prepared. But if it's like the other question, 2009, 2012, they're picking up on that, might not use that. Yeah. But that's average value. How do we feel? Pretty good? All right, so that's your exercises for today. You can do either exercise 11I, question 4, worthwhile practicing the integration by recognition, or you can work on average value. Those are the kind of questions I want you to work with. Okay. Now I'll leave it there. I'll pause the video too.